Hello, welcome to the March 2025 imaging meeting for SJAA. And tonight we have Doug Loyer. He's going to tell us all about AI and astrophotography. Hey, Doug, go ahead.
Hi. Hey, thank you for the invite and thank you everyone for coming. This is a really fun topic that I've been playing around with for a while. So we have a couple things to go over. Talk about the motivation for using AI for astrophotography, a survey of the pretty long list of models that are available, a deep dive in one that I call Stretch Magic, which is something that I've been playing around with and it's the first AI tool for stretching, which is something that I think a lot of people, really needs an AI model because it's kind of a pain in the rear end to do it by hand. And I think a lot of people that are particularly new to the hobby feel a lot of anxiety about. And then finally, I wanted to introduce something new that I'm calling Nebula Magic, which is a web-based AI-enhanced image processing tool for astrophotography. So here's my motivation for doing this. I first got a telescope a long time ago. And, I didn't think it was really that much fun, honestly. I got a little Meade 5-inch and you could, go see stars with it, points of light, but couldn't really see any nebula. And hey, it could find the North Pole and, that constellation, which was pretty neat, but it did not get a lot of use. But more recently, I was actually at the eclipse last year's solar eclipse, and someone had a Vespera, and I thought that was pretty neat because I didn't know what it was, and they told me it was a telescope, and I thought they were BSing me because it looked like something out of the game Portal, and it was much more modern. So I read about it, learned about it, and I was amazed by the capabilities of what these could do. And I ended up getting a C star. And I was very impressed by it. It's very reasonably priced and it has a lot of capabilities, super easy to use. The results are okay. They're goodish. You can go see a nebula, but it's kind of a gateway drug because it has very low adoption curve. It's very easy to learn and you can get a good result very easily. And so you want more. So that led me to getting, better equipment. It was kind of a downhill slide from there. Got an 80 millimeter, then 120 millimeter APOs, get guiding, get mono cameras, get filters, get, the whole rig. And, each step is a little bit better, a little bit better. But unless you want to just, live stack and use it for EAA, you need to do post-processing, which is a whole thing. And as I'm sure the members of this group know, PixInsight is the best, most flexible tool for doing it, purpose built, but also little difficult to learn how to use, kind of quirky, little dated. I'm a Mac user, and it'll work on a Mac, kind of, but it's not really designed for Macs. And most of the functionality has really been obsoleted by, AI tools, really. But, in order to use it well, you have to invest a lot of time. You have to watch a lot of YouTube. You have to find plugins, install plugins, learn how to use the plugins. But if you invest the time and fight the learning curve, you can get a pretty good result. And there's other platforms as well. Serial, City Astro, I think Graxpert also has a platform. Some are commercial. Many of these are free open source. They have to be installed. And obviously, if you're using AI tools, you need to get those installed and get them to run on your equipment. Um, because they are image processing models, typically they benefit from GPUs. But getting the GPU to work with it can be, a little bit challenging. So this is really, what's going on in the rest of the world as well. If you have a phone, sure you do. They have a lot of AI-driven computational photography methods built into it that, really improve the user experience and work amazingly well. They can, take good photos in low light conditions. They ought to do automatic high res, HDR. They do a lot of computational image enhancement, and these are not even things that are exposed to the UI. That's just how they work, just how they're done. And the same thing is happening now in astrophotography. This little Sea Star, $500 telescope. Well, I guess now with the tariffs, $550, but they have built-in noise reduction as well. And with all the plugins, they can do a much better job with it. BlurX and NoiseX really upgrade PixInsight and give you a much better result. And they've come a long way. They've evolved. And I feel like the effect this will have on the hobby will greatly reduce the barrier to entry to make it much easier for people like I did to become interested and with less effort, less time invested, get a result that they can share with their friends and show off and really look at these beautiful pictures I took from my backyard. And I think this effect will happen, pretty fast. So a quick, background on AI models and how they work. Traditional algorithms for things like noise and deconvolution, these were algorithms. They had to be understood deeply with all edge cases and written in terms of math. Um, and AI models work differently. Instead of having a mathematical derivation or all edge cases thought through and defined in terms of rules, you simply give the model examples and ask it to learn some relationship. And you define what good is by something called a cost function, and you define that cost function. For example, I used to work in with voice recognition models so that you could transcribe speech, and that would be a model where you give it a lot of samples of speech, and then you give it the transcript that might be written by hand, and it would learn that relationship. It would learn to recognize those words. Modern speech models now have over 1 million hours of audio, and they now can automatically detect pretty much every spoken language and do a better job of recognizing speech than most humans do. And these are things that we all interact with. And I'm sure seen call centers are becoming highly automated. If you go to a drive-through, sometimes that's not a teenager you're interacting with, that's now an AI. And this is the evolution of the technology. Some of these models can be very, very large and take a long time to train. But building these models, um, making a simple model can be very easy, very straightforward, but making one work well on any task can be a lot of trial and error and very labor intensive. And so the models that we use were really the result of someone investing that time. Here is the first, I'll go through a couple of different examples. Noise removal is a very obvious example. What you see on the right side of your screen is a toy noise removal model I made a while ago. And what I did is I gave it on the left-hand column are original images, clean images. And on the middle column is that image plus noise, some cases, a lot of noise. And the right-hand side is what the model tried to remove the noise. So that's the result of the noise. So the model was trained to remove that random noise, and that was the result. And as you can see, it can do a pretty good job. If it knows if it's trained on the kind of noise that's in your image, then it can do a really good job of removing that noise. But however, it is very sensitive to, how the image was collected, whether it was monochrome or one-shot color, if it was one-shot color, how it was debayered, all of those things, change the patterns of the noise. Another example is image sharpening, which you can describe as, if noise removal is, hey, I see some photons, but I don't know if I have the right number of photons. And image sharpening is, well, I see a photon, but maybe it wasn't in the right pixel. And Obviously, if you're looking at an astro image and you have stars, all those stars, if you were outside the atmosphere and you had ideal optics, then they would all be points, with, 1 pixel across. But because we have an atmosphere and we have, real optics with, diffraction limits, then you'll have, blurry stars that have a point spread function that are spread over many pixels. And they can be described with some very standard mathematical functions like Gaussian or Moffat descriptions. And then convolution models will attempt to recover the original image. BlurX is an excellent example. There's others, but you have to buy that. But there's other open source or Creative Commons models like Cosmic Clarity Sharpen. There are academic models like Noise Devoid. ESR-GAN is a popular model that came from academia. It can also sharpen, noise removal, and super resolution as well. So it can increase, upsample the image all at the same time. Here's a simple example. Here is an image with a lot of noise. I think this was maybe in 51 or 101. I can't remember what the target was on this. And then on the right-hand side is the same image with BlurX and NoiseX. Um, Most cameras sold are one-shot color cameras, as you might expect. I asked ChatGPT, we were talking about ChatGPT earlier, and ChatGPT thought that between 75% and 80% of all dedicated, actively cooled astronaut photography cameras were one-shot color. Obviously, they're a lot cheaper, a lot easier to use, a lot less planning. You can live stack, a lot of advantages to it, but they're not as, the image quality is not as good. Um, and Let me go forward. Here's an example of that. On the left is a monochrome image of M1, and on the right-hand side is M1 shot with a one-shot color. Both of these are the same telescope, and they are, very similar collection times and everything else. It's just a monochrome camera with filters compared to a one-shot color with a noise pollution filter. This was shot in my backyard. It was kind of a moon, had a lot of moonlight that contributes to the difference in quality, but also the camera is a lot sharper for monochrome. Um, how you process the image matters too, because gee, if you run a Chrome, then you have the full resolution. If it's a color camera, then you get different results, whether you do drizzle, if you use RCD from Serial or VNG, which is more common, PixInsight, that's the algorithm PixInsight it uses for debayering. You'll get different results. And if you think about what's really happening, well, half the pixels are green, but the ones in between have to be averaged in some way between those pixels. And the red and blue pixels have to be averaged, even more because, they're even further apart. So that will have the effect of changing the sharpness as well as the noise. And the noise is no longer independent pixel by pixel. Now they are linked. They depend on each other. And that makes it much harder to remove the noise. And the noise becomes more coarse rather than, pixel by pixel independent, fine-grained. Drizzle has some very nice properties in that area. So if you drizzle the image, this was developed originally for the Hubble to make the images far sharper or do higher resolution images. Smart telescopes, when they shoot mosaics, they have a very small sensor, so it's less expensive, and they have a very small field of view. But if you shoot a mosaic that overlaps, then they can be combined and you can have a much larger effective field of view. And you can also have, a really good quality image. And um, and another big advantage is that the noise is finer grain, more independent pixel to pixel, and thus easier to remove in post-processing. So when I do my processing, I prefer to use drizzle, but you need to dither your sub-exposures and have enough sub-exposures to cover all the pixels. Otherwise, you'll get blank spots in your final image, which obviously you don't want. Um, and then the two more models to talk about, types of models to talk about very quickly. One is obviously gradient removal. Gee, if you have a moon with partial glow, you'd like to be able to remove that image, and Grexpert does a pretty good job at that, but not always. It really depends on the image. Sometimes it does a good job, and sometimes less good. Sometimes it can cause other artifacts in your image. And then the original, I believe this was the first published astrophotography image AI image processing model, and that was StarNet. It was open sourced. And this is an example of what's called a UNet. And UNets, they take increasingly lower resolution versions of the image until you get down to 1 pixel by 1 pixel. And then they gradually increase the resolution until you have the original resolution. Again, there's a little description of the architecture, model architecture. And at each stage, then there are cross connects from the input to the output at that resolution. And so as you go deeper and deeper, the layers become thinner in terms of resolution, but they also become many more channels. So if you have a 3 channel RGB image to start with, at the end it may have over 1,000 channels for that 1 pixel in the middle, and then expand the resolution back up. This is a very popular architecture, often used for noise removal, star removal, object removal, any kind of generic image to image model, type, model. StarNet is an example of a unit. StarX is probably a unit as well, but obviously that's a proprietary model, and that's not published. So I want to talk about an AI model that I developed called Stretch Magic. Stretch Magic is a model for stretching your image. Um, Stretching it's kind of tricky. A lot of people have a hard time learning it. If you go into PixInsight, you can see the menu on the right-hand side from PixInsight. It has a lot of options for, what they call intensity transformation, mostly stretching. And everyone, goes through their options, tries to find one that works for them. Personally, I like curves, PixInsight curves. To me, that makes the most sense. So the question would be, well, gee, could you train an AI model to drive curves? And that's what I did. So I downloaded thousands of images from the internet, about 60,000 of them. And these are beautiful astrophotography images, ones that people put some effort into making them look, good. About half of them are one-shot color. The other half are monochrome in every kind of, palette, Hubble palette, every other palette, galaxies, nebula, anything you can think of. There's even some single channel monochrome in there, everything. And they all look, good. And then and then the model was trained to try to take any image and transform it, find the curves transformation that would make it publishable. Theory being that if someone took the trouble to make an image and publish it on the internet, that is a statement that this image is considered to be good by humans. And you can train the model to take your image and make it like that. It makes it more publishable, and it would make it, more presentable. So this model is hosted online as a web thing. You don't have to download anything. You can upload your image and use it. Um, and people are doing that. I first released this as an alpha to the San Jose Observers mailing list in January. If you read that mailing list, you may have seen it. A bunch of people from the list tried it out. I really want to thank everyone that gave that a shot, that tried it. It was hugely helpful. A lot of people uploaded all kinds of very diverse types of images and image formats. There were a lot of image formats that it didn't know how to read, like 32-bit TIFFs, 16-bit TIFFs. But it was easy to add, support for that. In February, I posted it to Cloudy Nights and had it's a bigger, environment, so I had a bigger response from that. And it's still getting some pretty steady use. I just recently did an upgrade to it. It's faster. It's faster to upload because you have to upload your images and they're pretty big, so it compresses them in your browser on the fly, which greatly reduces the time needed to upload. And the stretching is faster, but it also is a new AI model as well. I refreshed the AI model with more data. The original model had about 24,000, only about 24,000 images. And these kinds of models tend to get better when you give them more data and also add, a lot more diverse images. Um, and I'm really surprised by how much usage it's getting. Every day I look at it, and there might be, a half dozen people, in there, doing something, with it, which I think is pretty cool. Some people have asked for a PixInsight plugin version of it, which, yeah, I think would be a good thing to do. But the other thing I want to share is this new thing that I'm calling Nebula Magic. So we have Stretch Magic and we have Nebula Magic. Stretch Magic, I wanted to do that mainly because it was like the last big AI model you need to do for astrophotography. If all the other steps in the flow mostly have an AI model to do them, someone trained an AI model, or at least one model. In some cases, lots of models, but not stretching. But now there's a stretching model. And so now we have everything you need to go end to end with just AI processing. You don't really need to have manual steps anymore unless you really want more control and really want to be able to fuss with it. So I made and then the other thing was, well, gee, today, if you want to do astro processing, you need to download software into your computer, either buy or use one of the open source versions, install it in your machine. And if you are new to this, well, is that really the best way to do it? If you're new to this, I would think it would be much better just to go to some website and just upload your subs, and then that's it. And then you can get a usable image on the other side. And so that's what Nebula Magic seeks to do. This is a beta thing, it's new. Um, no one other than the people working on it, like, a couple other people have worked on this with me, have really used this. So if people in this group would like to give it a try, that would be awesome. Try it out. Let me know what you think. I'll give a demo of it. It also supports stacking. So you can give the original sub exposures, including your calibration frames, and it will stack them and then do the post-processing as well. If you're a C-star user, it can even do the C-star style mosaics, which they're not a bunch of exposures for one pointing. Each exposure is a different pointing. And that is very difficult to process using traditional tools, but you can just upload these directly and it will work. Currently, it supports only one-shot color. We'll add monochrome in the future, but for now, we'll start with one-shot color. And it does a number of different AI steps: noise removal, gradient removal, stretching. We'll add blur removal. We'll add, additional functionality, color correction as well, in the future. And then at the end, you can save your file. If you want to do further processing in Photoshop, you can use a TIFF. If you want to do further processing in PixInsight, then you can download a FITS file when you're done. If you just want to take your image and post it to Twitter or share it with your friends, then you can just get a JPEG. So at that, let me switch my browser and just give a quick demo. Can you guys see the screen?
Yeah, but the image is cut at the bottom.
Yeah, it's okay. We'll scroll. So this is an example. This is just one of the example images. And this is at the result of stretching. This is the original image. And so this is the raw stacked image that this came off the telescope and then stacked, no further processing. And, it's washed out like it, usually is. Run the algorithm on it, the model on it, and it's much, the background is darker, it's much more vivid. Um, here you can actually see the curve style transformation. When I use curves, I usually use like 4 or 5 points. This model generates 100. And wherever it's flat, you have less contrast. Wherever it's steep, you have more contrast, and it automatically adjusts for the luminance or brightness, and then also the color saturation channels, and then combines that. You do have some control. If you adjust, the strength of the model, then it will update. It'll just do that. You don't have to run any process. And you can for example, increase the saturation and, tweak your image that way. You can use either the old or the new model, but
Hey,
it's
Doug,
this
can I ask you a question? It
absolutely.
it looked like either your input image was nonlinear or it was auto stretched because, it was pretty visible. So,
Oh, great question. So the original image, if your image it'll look at your image. If your image was linear, it will give it an auto stretch. This is an auto stretch.
okay, thanks.
If it was already stretched, it'll just, all right, it was already stretched, and you can see it. Because otherwise, it'll just get a blank screen, and that's not very useful. In fact, if it doesn't detect that correctly, you can pick this option, and it'll just tell the model to leave it alone. Um, Likewise, there's always the question, do you do a linked stretch or unlinked? Usually you want an unlinked, but if you really do want to, if you already color calibrated, then you can use a linked stretch and keep the original colors. The model itself will not change the hue or color. It'll leave that to the ground truth. So this is a very simple thing. And then you can download the image when you're done, but this will only do stretching. This is a stretch model. Now, let me show you an example of, well, gee, if you want to upload your image, so I'm uploading a 100 MB image, and you could see it compress the image in your browser and then upload. And it's, fairly quick. And so this is an M1 image. This happens to be a monochrome image. You can see the original is pretty noisy and a little bit washed out. And then after the model runs on it, it looks, a little bit more like you would expect it to. And then you can, tweak the settings if you like, and make it, a little bit more, a little bit less to fit your style or your desire. Um, any questions at all about that? And then I'll switch to the other tool.
I could ask a question if no one else has one. Sometimes there's parts of an image you want to emphasize, like maybe you have an elliptical galaxy and you want to emphasize its arms, or there's some kind of, clouds that you're trying to bring out. Is there any control for doing that, or does it magically figure that out?
Yeah, there's no explicit control for masking. If you want to do a mask stretch,
I don't
this,
mean masking so much
yeah,
as, like I want the curve a little steeper in a certain range because that'll make yeah, anyway, you get the idea.
yeah, oh, absolutely. And that kind of control, I really kind of try to, debate like how much control to give the user. And for now, it just has the, more or less, which doesn't let you, fine tune that part. But then the model itself will try to figure out, which parts are the most, interesting, or the parts that
Okay.
have the
And
most
then
content.
is that the control that would adjust, let's say, how the background, how should I put this? The black areas, some people prefer it a little blacker, some people want to see a little more detail in the darks. Is that the adjust luminance strength, the control of that, or is there?
That'll have a big effect on that. It
Okay,
also depends, for example, that now you see more of the noise in the background. It depends also on how noisy your background is. If you're if you have or what kind of gradients you have. And so if you have a gradient-free image, for example, then it's much easier to stretch it, just like any other tool, because you have more contrast to work with. And if you have a less noisy image, then it doesn't have to, it has more range to work with as well. And then you can always reset back to the default. Okay, let me show this tool. So this is all pre-release software, so it's all beta. So there will be bugs, absolutely bugs. And I'm really curious to see, what people, think. There's a feedback button down there. It just fills out a Google form, and you can put, what your thoughts are, or if you have any suggestions, or if you found a problem or a bug, let me know if you could. Um, I already uploaded a bunch of C star files. I uploaded that before the call because it would take maybe a minute or so to upload this many files. So this is 103 C star files. Um, and I also stacked them. And it takes maybe another minute to stack them. Under the hood, it's really using Serial for the stacking. You can think of this as a web front end for Serial for the stacking. But if you wanted to also upload flats, darks, bias, calibration frames, you can do that here. And the C Star has already calibrated the frames. It's not needed for this instrument. But when I upload images from my ASI Air, then obviously I want those calibration frames. After it's stacked, you get the master. Now this is a C Star mosaic, and that's why the shape is so strange because it is drizzling 102 images that overlap. On the edges, there is less coverage, and so you'll have noisy areas. But then in the center is much more coverage, and you have a cleaner image. And so and so you can see these are 10-second exposures, 102 from a C star, and the resulting image is about 2500 by 3000 resolution. If we just zoom in, we can get rid of all those edges, and we can pixel peak if we want to pixel peak. And you can see, it's actually not that bad of an image. It's not super noisy. And then if we go to the Edit tab, this is where we can run our stretching, gradient removal, noise removal. We can just pick the options that we want, uh, run them. This is running in the background. And then we have, a better image, a stretched image. And then we can have some control over, how it's done. The comparison, the original master image, the stock master, and then the processed image, and then we can save it if for whatever we want to do. We want to share it with friends, just save as a JPEG, or we can save it as a TIFF if we want to bring it into Photoshop. Let me give you another example. These are some example images, but I can also show one. For example, we'll pick the Rose Nebula. Uploading 100 meg image. It's compressed. This is the Rose Nebula. We go into the edit, and we can run. I don't think we really need gradient or noise removal for this image. So we'll just stretch it. And yeah, it's a little bit brighter image. Maybe increase the strength a little bit and see if we get what we like. Still running. There we go. Maybe a little bit too much saturation. And I want to show one more example. And this is an example of a galaxy with a really bad gradient on this. So, gee, maybe the moon was out, and when this was shot, pretty strong gradient. So we can run the gradient removal model on this. Maybe turn down these a little bit. and see if that looks better. Okay, that seems a little bit better. Original, and then the process dimension. I think we can get down, turn down the green a little bit if we turn down the color saturation, make it a little bit less green. And then we can save that. So that's a AI model for processing your image. What do you guys think?
Hey, Doug, this is Sudhir. Great presentation and a really handy tool. I did get a chance to try it, I think last month when you sent the email. One question I had was, do you have any suggestions on the stars? I mean, this tool does a pretty good job of stretching with the stars on. Uh, do you have any suggestions on trying to remove the stars and trying this and going back to a different tool
Oh
and
yeah,
doing
yeah,
this?
yeah, absolutely. So I actually have a star removal model that will allow you to shrink the stars so you can control how big the stars are. And it actually internally what it's doing is modeling the point spread function of the stars and then reparameterizing them to make them smaller and then re-renders them as a smaller size. But the quality wasn't quite where I wanted it to be, so that feature is disabled for now. The other thing you can do is use a tool, like a blur removal tool like BlurX, that can also, sharpen the image, reduce the size of the stars, and make them much less noticeable. Yeah, I have it disabled from this tool for now, but it does give you control over how, noticeable or how, big those stars are.
And you would recommend the blur to be after this, right? Post.
Yeah, doing the blur X before and then, do stretching here would be one approach.
Okay.
Um, and that can reduce the size of stars. For example, if we go back to this image, you can see that. You can see, here's an example. Noisy and pretty large stars. Like take a look at this star side by side. It's quite a bit smaller. And I suspect that internally BlurX is doing something similar to that. It's modeling the point spread function and then re-rendering the stars. I think every time I looked at the star profiles from BlurX, they are perfect MoFat 4s.
Cool. Thank you.
Great question.
I just want to say, wow, I think it's fantastic. I had no idea this was possible.
That's really cool. That's really neat. Um, if you guys want to give it a shot, here are the URLs. They are nebulamagic.com for the stretching tool. And then if you go to app.nebulamagic.com, you can get into the full UI. And there's no login, there's no sign up, there's nothing to install. It's just a beta thing. Try it out. If you like it, awesome. Let me know. And if you find something that could be improved, let me know.
Hey, Doug, this is Rich Klein. I want to echo the wow and just ask, it seems too good to be true. Upload your stuff, it happens and it gets back down. What's the hardware behind it? Is it scalable? What if 100 or 1,000 people decide to use it? Are you dead or what happens?
Well, I'm a startup guy, right? So in the startup community, we have a term for that. We call that a high quality problem.
Uh, been
It
there.
is running on a server, Ubuntu server. I just have, sitting around the my office, and it's running a GPU. It happens to be a 3080 GPU that I used to use in a VR rig, and it is totally fine for light use. So if 40 people hit it all at exactly the same time, they may not have a good experience because the users would have to wait in line for the GPU. And it takes, a few seconds to process, each thing. But the reality is, few people a day might do it and is totally fine. Yeah, that's not,
That's kind of what I wanted to know.
yeah,
Looked really good. I'm looking forward to trying it.
awesome. Yeah, that's great. Yeah, let me know how it goes. It's what I call beta or really alpha software. The stretching tool is a little bit more mature. I think more of the bugs have been beat out of it, but the full flow is newer. And you may encounter a few things. Let me know, and we'll fix it. I'm working with a couple other people on this project because it's fun.
Hey Doug, amazing. I believe I tested a few of the images initially when you sent the email.
Oh,
Just
thank you.
curious, is
Yeah,
there a plan for making this available locally, right? Like, let's say I do an image session, I
yeah,
have gigs of data, right? And uploading
yeah.
gigs of data, uh, I don't know, for you, the internet was super fast. It looked like, you were uploading 100 megabyte files in a minute, I mean, in a second, but
Mhm,
mine is not that fast. So,
mhm.
is there any plan for like hosting it locally or something? Is that even an option or?
Yeah, there's two answers to that. One, the first thing I'll point out is that one thing that was really helpful, I worked with a developer who found a way to compress the image in your browser.
Okay.
So instead of uploading the whole thing, we can compress it before sending it, which really cuts down on how much time it takes.
Okay.
And it turns out that's most helpful for sub-exposures
Mm.
because your sub-exposures are only one channel because they haven't been debayered,
Hmm.
and they're usually encoded as integer FITS files, and
Right.
those are actually very easy to compress because they're mostly, close to zero.
Okay.
The stacked images are usually three channel,
Mm.
and they're usually, floating point or, higher resolution.
Okay.
And so those tend to be much larger, and they
Right.
also tend to be harder to compress. And so the hope is, well, gee, you only have to upload it one time, upload your sub-exposures. And we think in the future we'll be able to actually engineer out the need to upload your darks and bias frames because, well, they're the same. And we think we'll even be able to figure out which darks and bias frames to use because of the hot pixels. Every device has different hot pixels, and you can actually recognize what device was used.
Right.
More than one camera, say, oh, you're using your monochrome or you're using this one. So you'd only have to upload your flats and your lights.
Okay.
Now, the other answer is, hey, if you're a PixInsight user already, I think it'd be
Yeah.
really awesome to have a plugin,
Yeah,
just like
absolutely.
BlurX.
Yes.
Yeah,
Yeah.
just like BlurX or NoiseX, something you can just download and install and run it locally because you're already doing your processing there.
Right.
But obviously, you'd have to have PixInsight to use that.
Right. 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 Yeah.
Yeah. So great,
Thanks.
and thank you again for trying it out, being a beta user for Stretch Magic. The feedback that was awesome.
Sure. Yeah.
Yeah, yeah,
Hey, Doug, I wanted to ask you a question. You mentioned that, you got a lot of images. You determined sort of what a good image looks like,
yeah,
or the net did anyway.
yeah, yeah. The internet did.
So I have two questions for you. One,
Yeah,
do you think it would be useful to score images for people? Like tell people what your net thinks about their, I mean, it might be insulting, might not. But but anyway, you could I suppose it's easy to give a score to an image now and say, does it seem like a good image based on the population of images? So that's a suggestion.
that's super interesting. I in my professional life, I did a project related to that where we would ask a LLM some artistic opinions on things. and it gives a surprisingly coherent answer. And you can also ask it to justify its answer,
Yeah.
explain it. Um, yeah, or maybe, suggest, what how to process it. You could see that as being
Right.
maybe,
Like you could say, I can't decide, between these two versions or this stretch or that stretch. What do you think? And it might advise you, sort of like we were saying about these current AI systems. It could act as an advisor to people using PixInsight even, uh, which is a totally different application than what you're doing,
yeah,
but maybe a useful one.
that's a pretty
It
cool
would be
idea.
nice to, when I'm processing, have some AI expert giving me, I don't have to listen to it. When I play tennis, I flip my racket, spin my racket to decide if I want to serve to the forehand or backhand. But my rule is I don't have to listen to my racket. If I disagree, I can do it my way. So I think it's the same thing. The AI could give you advice or could answer questions. Anyway, there you go.
I
My
think that's a
second
great
question,
idea.
my second question or comment has to do with, how much you want to reveal about what's under the covers. But let me ask it anyway and let you answer it the way you feel. Um, so, I can understand how you could make a model for, is this, how far is this from the ideal nice image, or is this within the cluster of nice images or sort of far away from it or whatever. But going from there to, I'm not sure I understand how to go from there to, so how do you take a certain image and give it a curve that makes it, that puts it in that cluster of nice images?
Yeah, so essentially it's within AI development, a lot of it is trying to figure out how to ask the question and how do you define what good is. And once you do that, everything falls from that. There are so many ways this can be improved. So essentially, it seeks to find the stretch that would make it consistent with those really good images. But for example, today it does that with the stars. There was a question earlier, well, what about the stars? Well, there's one, fairly obvious improvement would be, well, run a star removal model first, stretch the starless image, because that's a very common technique that a lot of people use, and they use it for a reason because it increases the dynamic range by a lot. And that lets you, focus on the things that, are more interesting to the user. And I thought your idea was actually really good too. If you had a way to the user could indicate, the area that's most intriguing to them, that could give them a little bit more control over the process. Because it's really not very clear how users can, give, give that guidance, exert that control. It's not very satisfying to upload an image and, oh, here's your image, hope you like it. That's what you get. You want to have some artistic influence over it. It's more satisfying, it's more creative, but at the same time, you don't want to be completely overwhelmed with so many options, and it's so hard to make something turn out good. It's more like you want to be able to choose among good options, good alternatives, but they have very different styles.
Yeah. Well, that sort of goes to the advisor idea that I was
Yeah,
bringing up. You could
yeah,
imagine it giving you advice. Well, next thing I would do is,
yeah. Or it could even be prompted. Could you make it, I don't know, more like this?
Nick says a recommender AI model. I'm not sure what Nick means by that, but that's a comment he just posted.
Oh, okay.
Is that a existing model, Nick, or something you want a kind of model? Anyway, we'll find out. Yes, Facebook uses it, Nick says. I guess Nick doesn't have audio or something. Okay.
Hmm. Okay, cool. I heard the fan on the machine kick on, so I think that means somebody was trying it out. Awesome. Thank you. I hope you have a good experience with it.
All right, so that's the end of your talk. Is there we're happy to entertain more questions as long as folks would like. Um, so please speak up if you have any more questions. Well, maybe that's it.
Awesome. All right. Hey, thank you for attending, and yeah, give it a shot.
All right. Thank you so much, Doug. Really appreciate it. Thank you, everybody else, and hopefully we'll see you in April with a new topic. And until then, so long, everyone.